In this video, we are going to learn about the characteristics of quadratic functions. A parabola is a graph of a quadratic function. Each parabola has a line of symmetry, also known as the axis of symmetry. The line of symmetry divides a parabola into mirror images. The line of symmetry is always a vertical line of the form x equals n, where n is a real number. The x-intercepts are where the parabola crosses the x-axis. X-intercepts are also known as zeros and roots. So, x-intercepts are the same thing as zeros, which are the same thing as roots, which are also called solutions. So whenever you find the solution to a quadratic equation, you're finding the x-intercepts. These four words are used interchangeably. They all just mean x-intercepts. The y-intercept is where the parabola crosses the y-axis, and the turning point of a parabola is called the vertex. The vertex will either be a maximum or a minimum value of the graph. It will be a maximum value if the graph is a downward-facing parabola, meaning that the equation will have a negative a value, and it will be a minimum value if the graph is an upward-facing parabola, meaning the equation has a positive a value. Excuse me. Let's go ahead and look at example 1. It says label the quadratic function graphed below. So, this curve that we see right here, this U shape, this is known as a parabola. Where the graph crosses our x-axis, so where it crosses this line right here, because remember this is our x-axis, is where we have our x-intercepts. So this point right here and this point right here are known as x-intercepts. Where our curve crosses our y-axis is known as a y-intercept. And so it's crossing our y-axis right here, and so this is a y-intercept. Let me spell that out. The turning point of this U is right here. This turning point is known as the vertex. And then line of symmetry and axis of symmetry, they mean the same thing. And all that the line of symmetry is a vertical line that goes straight through your vertex. Whenever we draw our line of symmetry, we always use a dashed line. So here are some of the characteristics of parabolas. Remember, this shape right here is called a parabola. In this example, our vertex is a minimum value because this is the lowest point of the graph. So if we were looking at this equation, it would have a positive a value. Remember, standard form for quadratic equations were ax squared plus bx plus c equals 0. Here, a, that's the a that we're talking about. So if a is positive, your graph will be a U shape like this. And if a is negative, then it would be upside down. So it would be more like an N, and that is when you would have a maximum value. But this one is a minimum because it is the lowest point of the graph. Let's go ahead and identify the characteristics on the next page. So here, the first thing that they want us to find is the vertex. The vertex is the turning point. So on this graph, it's going to be this point right here. This is the point 0, 1, 2, 3, 4. So this is the point 0, -4. Next, they want to know, is the vertex a maximum or a minimum value? Well, this point is the lowest point of my graph, so this is a minimum value. Your line of symmetry is a line that cuts the graph in half and it goes straight through the vertex. So this is the equation x equals 0. Your equation will always x equals a number, and the number will always be the x-coordinate of your vertex. Your zeros are the same thing as x-intercepts, and that's where your graph crosses your x-axis. So we have two x-intercepts, one right here at the point -2, 0, and another one right here at the point +2, 0. Your y-intercept is where your graph crosses your y-axis. Well, that's happening at my vertex, and that's at the point 0, -4. Go ahead and pause the video and see if you can identify those same characteristics on example 3. So on example 3, first thing that we want to do is we want to identify the vertex. Your vertex is your turning point, and so that's happening right here. So let's see, this is going to be the point 1, 2, 3, 4, 5, 6, 7, 1. So this is the ordered pair 7, 1. Is this point a maximum or a minimum value? It's a maximum value because it is the highest point of the graph. The axis of symmetry is the same thing as a line of symmetry, and that is a line that goes straight through the vertex and cuts your graph into two pieces. So we have this piece and this piece. Your axis of symmetry is always an equation. It is always x equals a number, and that number always comes from the x-coordinate of your vertex. So our axis of symmetry is x equals 7. The roots are the same thing as your x-intercepts. So I have an x-intercept here, and that is a point 6, 0. And I have another x-intercept here, and that is a point 8, 0.